So last Friday, you took a summative quiz. That means ending the unit over your conic sections and then the newer stuff, the conic applications, the sequences, the series that we had been working on the first week of remote before break and then reviewing last week. So I've already posted those scores in campus if you haven't seen them yet. But here is an overview of the quiz. So you can you can check along. I'm gonna return them. I've never given a Google quiz before that I've returned, I guess. So I'm going to hit a button that says return, and my assumption is that we'll go back to you. I don't know how it goes back to you. I don't know if it goes back into your Google Drive or what it gives you, but we'll have to work through that. The first question everybody got right. Everybody who took it got their name right, so that was awesome. Um, the second question was almost perfect. Um, there was one person who missed it, who thought they were in seventh hour when I guess a couple weeks ago they were actually in sixth hour. I don't I don't want to embarrass them too badly, but their initials are B. Johnson. So good job, Briar. That was pretty amusing. As you can see, seventh hour was the biggest class, and sixth hour was the smallest class. Probably because somebody was in the wrong class, right? This is the raw data. Um, 31 out of 43 would not be very good, but three of those points were bonus points, and so really 31 out of 40 is in the high C range. The median 32, so that means half the scores were above 32. That's 80%. So half the scores were 80 or above, half were 80 or below. Um, and you can see that the most common grades were in the A range, 36s and 39s. There were certainly a couple that were above in A big chunk here in the B to mid C range. And then unfortunately, there were a little thick section here in the high D to low C range. So a little bit of everything, pretty scattered, high standard deviation on this quiz. And I imagine with the remote learning, some people are catching on to it more quickly than others, and some people are probably finding it difficult to motivate yourselves. I get that, but um, if you are trying and you're struggling, very few people come to the help sessions and ask questions, and I think that you're going to have to start taking that extra initiative. And if you're just not getting stuff done, you're going to have to start getting stuff done. I mean, I know a lot of people are probably gambling that the grades are going to be locked where they are, but that is not been determined yet. There there's a committee discussing that, but I would not count on it because the vast majority of teachers and administrators at Chatfield are pushing to have grades go on as normal. Um, there's a little section that gives us the most frequently missed problems, and although there were a couple others that were not great, number 14 was particularly bad. That was the last question, and so we'll definitely look at that one. Only 5 people got it right. Multiple choice. Most of the questions were multiple choice. Question number one um, asked you to do some graph matching. It looks like right off the bat we know that this thing has to be an ellipse because the fractions are subtracting, not adding, and luckily all of them are. So we know that it has to be an ellipse. It's a positive x squared. Positive x squared minus y squared is a horizontal ellipse, so we get rid of option 2. It looks like the center of the ellipse is 3, right? H is 3, K is -2, and these two both have 3, -2. This one has -2, 3, so we get rid of that guy. And this is actually very similar to the quiz you took um, before remote learning began. About half of you picked them up, and it really came down to getting the C value correctly. So a squared plus b squared equals c squared. If we add 25 and 39 together, we actually get a perfect square. We get 64. And so we need to find the one that had the foci 8 units away. So 3 plus 8 is 11. Well, that looks like it's at 11. This one doesn't. This one's even less than 10. So that's why A was the correct answer for number 1. And most of you agreed with me on that one. Um, in fact, yeah, look at that. 94% of you got that one right. That is awesome, man. Awesome. Number 2 gave us another hyperbola and asked where the vertices were. So we need the center. Well, it looks like the center of this guy is -3, right? H is -3, so -3, 2. We also need to know the a value. Well, the a value for ellipses, the a value always has to be the first value because it's the bigger or the bigger value, right? I guess it could be first. Some people write it first all the time. But for hyperbolas, a squared is always the positive with the positive fraction. B squared is always with the negative fraction. So a is 3. The square root of 9 is 3. So the only question here is, do I need to add 3, to the x or to the y? That's the question we need to ask. This is a positive y squared ellipse, or a hyperbola, sorry. So that means it's going to be vertically oriented. So we're actually going to go up and down 3 units from the center, find the vertices. And we started at 2, so the x value is not changing. We're going to stay at -3, but we're going to go up 3 and down 3 from 2. So that's going to be, 5 in this direction and -1 in this direction. So -3, 5, -3, -1. And sure enough, the answer was D. And wow, 94% of you guys got that one right. That is flippin' sweet. Gosh. This is the first one that's in general form. They tell us it's a parabola, um, which only parabolas have a singular vertex, right? Not vertices. But because there's only one squared variable, we would have known it was a parabola. So we have to do a little math to get it into standard form from this general form. And then we can look at the h and k values. So let's factor out that 3. All right. We need to complete the square. So half of 3 is, oops, that, it's a 2, sorry. 6 divided by 3 is 2. Half of 2 is 1 squared is 1. All right, so that's cool. But I can't just add something to one side if I don't add it to the other. So it's not really a 1, it's really a 3 times 1. So let's add the 3 there. And I'm going to get 3, this is going to be y minus 1 squared. And this is going to be 6x minus 12 after I add the 3, or 6 times x minus 2. It doesn't really matter that we have this extra 3 over here. I mean, in standard form, we wouldn't want it, but this isn't asking us about the p-value. This is just asking us where the vertex is. So really, we already have what we need. We have a value of 2 for h and a value of 1 for k. 2, 1 is B. Right? And yeah, pretty good. 93% of you guys got it right. Very nice. Question 4. What is the equation of a conic section that has a center at -2, 3 and a vertex at -6, 3 and a focus at 4, 3? So this is a really good one to do a little sketch and just get an idea of what we're looking at. It doesn't have to be perfect, but just a little bit of an idea. So -2, 3 is our center. -6, 3 is our one of the vertices, or maybe the vertex, and the foci is, well, it has a center, so it can't be a parabola. The focus is at 4, 3, so kind of over here. This is the focus. So it's a horizontally oriented something. Let's take a look. The vertex, so that's our A value, right? The vertex from the center is 4 units away. From -2 to -6 is the distance of 4. The foci, so that's C units away, right? From -2 to 4, well, that's still of 6 units. Knowing that the foci are further away than the vertices, it means it can't be an ellipse. So it can't be this guy, it can't be this guy. We already knew that it couldn't be a parabola. And so now you're just down to these three. Now, they told us the center was -2, 3. This has a -2, 3. This has a -2, 3. This has a -2, 3. Oh, but it is horizontally oriented, isn't it? This focal axis is going left and right. So it can't be a y squared minus x squared. We said the a value was 4. Well, that doesn't help us because these both have that same a value. The C value is 6. Now that's the kicker right there, because it looks like they used the C value instead of the B value when they squared it there. That's C squared, but it should be B squared. Now, if we really wanted to get this, we would use A squared plus B squared equals C squared. This is 36. This is 16. And so once we subtract 16, 36 minus 16 is 20. So there's your solution on that one. Which was 3. Okay. So some of them were easy to get rid of, and then we had to get all the way down to B and C for the final answer. 81%, so it's, over 80% of you guys got it. This one was a little bit trickier. Notice how most of the people that missed it did option 1. So at least you were picking the 2 that we had narrowed it down to. You just got confused between B and C. That's the mistake you made. Okay. So not bad, not as exceptional as the first 3 problems, but not bad. Problem number 5. Um, well, first of all, we know exactly what it is. It's a downward facing um, parabola. So that means that it's an x squared parabola, not a y squared parabola. First of all, it's not a hyperbola or an ellipse. It's not a y squared parabola because those go left and right. And so it has to be one of these guys, doesn't it? It looks like the vertex is at -4, -2. Well, this vertex is at +4, 1. So that would have been like over here somewhere, I think. So it's not that one. Actually, it's not -2. It's -1. Sorry. Um, well, this one has a -4, -1. This one has a -4, -1. So it's got to be either option. These are actually not 3 and 4. These are options, 5 and 6. It's going to have to come down to that p-value. I mean, we know that we're looking at an x plus h squared equals 4, and we know that p is negative, and then y minus k. What is that value of p? Well, p is the distance from either the vertex to the directrix, or it's probably usually people go from the vertex to the focus. So that's a distance of 3. So knowing that p is -3, by the way, it's negative because we're opening downward, right? If I plug 3 in here, we know that p is negative. 4 times -3 is -12. And so that's how you had to distinguish between option 5 and option 6. Option 6 was the winner. I bet most of the people that missed this one picked option 5. Let's see. Um, well, barely. I mean, first of all, like 90% of you got it right, which is awesome. You're all awesome. But yeah, 4 people picked 5. Now 3 people picked 2, which just was the wrong squared. Y squared, y squared parabolas open either this way or this way. Okay, so that's why you missed it if you picked B. Okay, problem 6 is a We're looking for a standard ellipse whose major axis endpoints are. So once again, a little sketch goes a long way to helping you get an idea of what we're dealing with. So here's an axis, and we have points at -8, 1 and 6, 1. Okay. So what this means is it's going to have to be an x squared over a squared ellipse because it's going left and right. So a squared has to be under the x squared. Now, I bet we can get h and k really quickly here because the middle of -8 and +6 is, I think, -1, right? That's a total distance of 14. And then half of that is 7. So 7 up or 7 down, -1. Or you could add them together. -2 divided by 2 is -1. But -1, 1 is the center. So where's my -1, 1? This is +1, 1. +1, -1. This is +1, -1. This is -1, 1. So that one is a possibility. This one's -1, 1. That's a possibility. And I think this one only had 4 options. So let's see here. We already said the a value was half of 14, which is 7. Well, there you go. A squared, which 7 squared is 49, has to be under the x squared since this is a horizontally oriented ellipse. And so number 4, right? Yeah, wow, 93%. That is delightful. Find the foci of this ellipse. So we really just need to know the center and the orientation and the C value to find the foci. Well, the center is what, -4, 5. And it looks like this time the bigger number's under the y squared. So this is going to be an up and down ellipse. So let's see here, -4, 5. It's going to open up and down. The a value is 9. The b value is 3. But more importantly, a squared minus b squared equals c squared for any ellipse. And 81 minus 9 is 72. Root 72 is root 36 root 2. So 6 root 2 is c. And we're adding it to the y value because we're going up and down. And so when we look at our answers, it looks like the only ones that have the, the 6 root 2 are these two. And it looks like, what happened? It looks like this one added it to the x value, so that would have been moving that way. We know that for ours, the foci are going to be here and here. So I bet you that number 4 would be our answer. And how many of you said number 4? 88%. That's pretty good, pretty darn good. You can see that the majority of these problems you guys did really well on. Okay, now we get to sequences and series. Find the sum of the terms of this guy. Well, it looks like, first of all, it's positive, negative, so it can't be arithmetic. Arithmetics either go up or down. They can't change direction. But alternating geometric series can. So let's do our formula, right? Our AN formula. It's the first term multiplied by the common ratio. How do I get from here to here? Times -2, here to here, times -2, here to here, times -2 to the n minus 1. The formula for this is going to be 1, -2 to the n minus 1. The sum of this from 1 to what? So this is the one thing we really have to figure out. So I'm going to take my -2 to the n minus 1, except I'm going to pretend it's a positive 2. And I'm going to take the last term, and I'm going to pretend that's positive, just for the sake of finding how many terms there are. You can't solve for negative arguments and negative ratios using logarithms. Logarithms don't deal with negative numbers like that. So just for the sake of figuring out how many terms there are, we'll do that. So it's going to be log base 2 of 32,768 is equal to n minus 1. Now, because of the state that we're in, I think you're going to have the ability to just plug this in as you see it to your calculator. I mean, if it wasn't, we would do natural log of 32,768 divided by natural log of 2. It's easy enough. You just have to remember the change of base formula. But let's go run log base 2 of 32,768 through the calculator. Give me a new page. Come on, what's wrong with you? There we go. All right, so we'll use template. We'll use there it is right there. The base was 2 and the number was 30. See, I've been away from the document too long now. I don't remember that long. 32,768. 32,768. I think if it's not an integer, I know I did it wrong. 15. 15. All right. Now, by the way, if we did natural log 32,768 divided by natural log 2, check that out. Same thing. I didn't divide. Oh, geez. Such problems for old people in technology. Someday they'll understand. See, same answer. So, but if you're not locked out of this mode, you might as well use it, right? I mean, heck, why not? This was 15, and 15 plus 1 is 16, and that's it. I mean, you can now use your formula, which is the first term, so that's not going to really change anything, over 1 minus the common ratio raised to the number of terms, which we now know is 16, and we're going to divide that by 1 minus the common ratio. So whatever fairly large number this is going to be, we're going to divide it by 3, and that's going to be your answer. And let's see what that ends up being. All right, so for the sake of saving a couple seconds, I just plugged it in over here for us. I will point out how important these parentheses are. If you don't put the parentheses in, it may do order of operations incorrectly for you, but looks like negative 21,845, which looks like it's D, the last one, right? And, I mean, this is the one that we've struggled with the most so far, but it's also a geometric alternating sequence. So the fact that 75% of you got it wrong, I'd probably personally feel a little better than meh. I mean, it's not the greatest we've done so far, but SpongeBob might be a little critical there because this was the hardest problem that we've had yet. Now, this one was a little more straightforward. It was just an arithmetic sequence. It's going up 3, or I'm sorry, up 4, up 4, up 4. So 4 and, 4 times 1 is not negative 6, is it? It's 4. So I'd have to subtract 10 to get from 4 back to negative 6. So that's our formula. We're starting at 1. How far are we going? Well, if we set it equal to 70, looks like we're going 20 terms. And so that looks like 26. It looks like we're going to be doing number of terms, the first term plus last term divided by 2, This 2 is going to cancel that 20. That's going to give us a 10. Negative 6 plus 70 is 64. So what is that, 640? So now you're hoping that we have a 640. Oh, look at that, we do. And most of you guys knew that. 94% is one of the highest ones yet. So nice eyebrows, Mr. Murray. You're awesome too. Yes. All right. Oh, now we get to the fun ones. To help bolster its remote learning capabilities, um, Chatfield decides to put a massive satellite dish on the top of E-Wing. Um, Mr. Klinger immediately claims that it's helped him converse with his alien comrades. I actually believe that. That may be true. Anyway, if the receiver for the dish is 5 feet from the vertex, so the receiver is where the focus goes. So they're basically giving us the focus. I'm going to make mine go horizontally. You could have done it vertically and it would have been fine. This is what the two-dimensional parabola would kind of look like. It would come down deeper, possibly. It would be kind of 3D. It would be a dish, but I think you guys get the point. So they're telling us this is, 5 feet. So they basically just told us that the p value of this parabola was 5. The total depth of the dish. So if I came all the way out here to the very end, is 16.2 feet. Well, that means that this, um, half of that would be 8.1, right? So the y value up here is 8.1. What is the maximum diameter of the satellite dish? Oh, the depth of the dish. I thought they said width. Okay, my bad. So actually they gave us the x value. So they gave us this. 16.2 is the x value. We don't know what the y value is. We need to find the y value of this point. And then I guess probably double it, because that only tells us this. And we really need to get all the way here, right? So now that this is a really sloppy problem, let's see if we can put it together. I know that because it's centered at 0, 0, h and k are 0. I know because it's going sideways, it's going to be a y squared equals 4px. I know that y is unknown. I know that p is 5. That's what we found right here, right? And I know that x is 16.2. So this is where we do a little math. I guess since you have your calculators, you might as well use them. 4 times 5 is 20. I mean, you could do 10 times 6.2 is 162, and then double that and get 324. But we'll verify that. All right, so 20 times 16.2, it is 324. And I think that you're actually going to really like that value, because it's a perfect square. If you take the square root, you actually get plus or minus 18, because negative 18 is a point on the parabola, and positive 18 is a point on the parabola. How far is it from positive 18 to negative 18? It should be 36. So your answer on this one would be D, I guess, 36. So this one was a rough one. About half of you guys got it, but you can see that even I started to make a mistake. I initially put an x value for a y value and had to make an adjustment. But application problems are, you gotta read through them. You gotta understand what you're looking at. So that's the way it's going to be. Some of these are tougher than others. This one is about a comet that is orbiting the sun, and then its orbit got changed. This is actually a true story. This comet was discovered, I think, back in 1978 by a guy named Wild, and so it looks like wild, but it's actually a Swiss guy, I think. Wild is his name, and so I think this comet's called Wild 2. And it really had a long thing, and then it got too close to Jupiter, and Jupiter yanked it. It changed its orbit around the sun. So it's kind of an interesting story if you want to read about it. Um, but we do know that you know comets that belong to our solar system, um, they are elliptical. So if we have a star, which for us would be the sun, it's going to be at a focus. And I also know that the distance to a focus is c, and I know the distance to a vertex is a. And so the perihelion, which is the closest you ever come, that's going to be this distance right here, is going to be your a, and then minus your c, a minus c. And so a minus c is equal to 1.6. And the aphelion, which is the furthest you ever come from the star, the sun in this case, is a plus c. A plus c is 5.4. So the aphelion is 5.4. So we have a system of equations. The easiest way to solve this one is just elimination. You add the equations together, you get 2a equals, and what is that, 7? So a is 3.5. So a is 3.5. And what did they ask for? They asked for the eccentricity. Well, the eccentricity, of course, is c over a. So I now know that a is 3.5. I don't know what c is, but I know that that a is 3.5. So if I just go into this equation and put 3.5 in for a and I subtract, I think I'm going to get 1.9 for c. So let's test that out. 1.9 divided by 3.5. 1.9 divided by 3.5. So 5.5, 42857. Um, this says to round your answers off to the hundredths place. So this is where some of you guys may have missed it. These are tricky. I'm going to tell you, I haven't built Google quizzes before, but what I'm learning is that I have to enter the answers here. And if if I don't include an answer, it will not get right. So like if I put in 0.54 and you put in 0.5, that's not going to be right. So like, maybe you only lose a partial credit point for rounding off incorrectly on a free response. On this Google type of thing, it's going to take the full chunk off. So you really do have to be careful and read the directions. Now, 0.54 is also rounded off to the hundredths place just with the zero. So I did actually put these two values in. And between the two, most of you guys got it. Now, not most by a lot. I mean, it looks like, what, 61%? 61%. So on a problem like this, not bad. Um, but it looked like there were a whole bunch of people who got lost within the math. So hopefully that helps you on that one. Now the last ones were multiple select. These can be really difficult problems because you have to figure out which ones are true and which ones are false. You basically have to answer 4 or 5 or 6 true false questions in a row correctly to get full credit. That is tough. This one right here is another geometric problem. And it looks like it's going up. Well, 2 is the first term, right? And it's going up by a multiple of 4 each time, times 4 times 4 times 4. So that's your formula. 2 times 4 to the n minus 1 is equal to 2097152. Holy cow, let's divide that by 2. 4 to the n minus 1 is equal to 2097152. 2017952. Holy cow, did I get that right? 2097152. 2097152 divided by 2. So 104, 8576. 104, 104, 85, 76. So now we have to use our logarithms. And I'll tell you what, I think you can trust me on this. I'm just going to do a handheld calculator. It'll go faster. But the log base 4 of 104.8576, plus 1, once you solve for n, is going to be 104.8576 divided by 4, and then plus 1. So it looks like it's 11. It looks like when you add the 1, it's 11. So if you forgot to add 1, you probably would have liked this one, but it actually is not wrong. Now, we during this formula, we found this formula, so we're good with the right formula. Now that's definitely something we'll accept. Um, what's the sum of the terms? Is it this guy or this guy? I gotta tell you, it can't be this. I mean, this guy is in the way. This term right here is less than the last term right here substantially. You can't add a bunch of numbers and it's less than the first number. So these two are out. So we just got to figure out if that's the right answer or not. So it would be the first term multiplied by 1 minus 4 to the 11th over 1 minus 4. 1 minus 4, by the way, right, is negative 3, so negative 2/3 if you take those two pieces, and then 1 minus 4 to the 11th. So what the heck is that? I'm actually going to do this. It's probably going to be easier to enter it here. So negative 2/3, and then 1 minus 4 to the 11th. So 279, 6202, 279, 6202. So there you go. Wow, look at that. 94% of you guys got the first part right. 87 got the second part right. Now, I had to get them both right to get the overall right, so probably more along the lines of 87% of you guys got this problem right. But that is a nice job. That is well done. Now, this guy was a little easier because he was arithmetic, and the formula is going up by 8 each time. 8 times 1 is not 4, though. 8 times 1 is 8, so you have to subtract 4. So it looks like this one's good. 8n minus 4 equals 132. 8n is equal to 136. 8 goes into, well, 8 goes into 80 10 times. And then let's do 64 would be 144 would be 18. So one less than that, so 17. Yep, looks like this guy's right. I mean, if you write the formula out, which is the number of terms multiplied by the first plus the last, basically averaged, right? I'm pretty sure that if I'm starting at 132 and the number before that was 124, I'm already really close to 272. I think this is way too small. If I think about just adding a couple numbers in the hundreds, it's going to blow way by this. This one's feasible. Let's check it out. What is 17 times 136 divided by 2? Well, 136 divided by 2 is 68. 17 times 68 is 1156. And so, yeah, there you go. So we had this guy was good. This guy was good. And this guy was good. And it looks like the vast majority of you guys figured that out. Now, not everybody. So some of you guys may have missed this because you didn't get them all, but still, nice job. Very groovy. All right, so this is the one that only like 5 people got right. So this, you know, I don't know how long this video is. It feels like it's really long already. So hopefully, if this is the only one you missed, you fast forwarded it all the way through. Um, I'm going to set it equal to 0. So I'll bring the x squared over, and I guess we could leave the constant 20 on this side. Um, Factor out of 4. By the way, it's an x squared and a y squared. It's not a parabola. They're both positive once I set it equal to 0. So that means it's an ellipse. But notice that they're both the same. That means it's a circle. Okay, and that's going to make a big difference here as we uh, go through and solve this. Um, this is going to be a 1, right? Half of 2 squared is 1. That's really going to be a 4. 4 times 1. Half of 4 is 2 squared is 4. 4 times 4 is 16. So it looks like we're really going to get 4x minus 1 squared plus 4y minus 2 squared is equal to 40. And here's where I think a lot of people may have made the mistake. Um, if you divided by 40 to set it equal to 1, you would have gotten a 10 at the bottom. And I think you would have said this is true. At least one of the denominators in the standard equation is 10. The problem is a standard equation for a circle doesn't have denominators. The standard equation of a circle is x minus h squared plus y minus k squared is equal to um, r squared, and 40 divided by 4 is 10. So it looks like if 10 is r squared, then first of all, there are no denominators. There are no a values. There's only an r value. Now the square root of 10, as it turns out, is um, about 3.16. So I think this one's good. But if you just said the radius was 10, then you would have got that one wrong. It's not an ellipse. It's a circle. And the center is at 1, 2, HK. So this one looks good. Not 2, 1. And focal lengths, yeah, circles don't have those. Circles don't have foci because they've collapsed in on the center. So I think a lot of people just didn't recognize this as a circle, and that got them in trouble. And let's take a look at the breakdown here. Oh yeah, whoa, that is some rough data. Look how many people thought the first one, it was true that it had a denominator. So that's just making sure you understand the standard equation of a circle. A lot of you guys, over 50%, said there was an a value, but then you also said there was an r value. Basically, you're saying they're the same. Once it becomes a circle, you don't have a's and b's anymore. They're equal to each other. We call them r's, radii. There were 7 people. That's not too bad, who forgot to take the square root of 10. But the one thing I do like is that the 2 answers that were correct were the 2 most often picked things. I think we had too many people picking things that were not true. Maybe there were too many choices, and you were freaking out. I mean, 8 choices is a lot. To get 8 things in a row correct, 8 true/false questions in a row correct is a lot. But that was the most missed question. If you really want to see how you do this problem, you just want to go back to, I think, page 10 or 11 when we were doing those application problems and look at the same exact thing. In fact, hold on one second. So this is the thing I love about recording. It just took me like 4 minutes to find this, but to you, it was instantaneous. So as I look at this, this is the example from your notes back on, I think, page 11, maybe 10. But it's this rogue comet question. And you have a comet that comes in from outer space, goes around the sun, and then shoots back off into space. And actually, I just want to put it through the center. It should be coming through the vertex. So it's kind of like that. This is the exact same problem you're looking at here. And so, you had two of them out of the textbook after we did this example together. You had another one in the textbook review. So it's probably the fifth or sixth time you've seen it. Now, I did make it a bonus because I do know that there's a lot of moving parts to it. But if you look through this, it gives you that C minus A perihelion value of 90. So, we would replace that with 180. And it gives you a focal axis. So that's, half the focal axis is this distance right here, 441. In this problem, it was 281.5, 281.5. So there it is right there. So if we just replace 180 for 90 and 441 for 281.5, it's really the same problem. And if you never did this in your workbook or you never copied these notes off the internet, the calendar, then no wonder you didn't know how to do this problem. I mean, it's a lot. It takes practice to get the system of equations down. But basically, what we've got going is that the perihelion is C minus A, and they give that to you. And the half focal width, and you did have to remember that it was B squared over A, although you could have looked it up in your notes, right? Open note quiz. And once you solve both of them in terms of A, you can substitute them in, and then you just do some algebra. The A squareds actually cancel, so it's not even a quadratic, and you get your answer. Now here the answer was 80, but with the problem on your quiz, it wasn't. But I did make them based on uh, primitives. So I chose numbers that would be integer values. And so when you got A, it was an integer. When you got C, it was an integer, and then C divided by A, um, or C divided by A was the eccentricity, and it turned out to be 1.45. Okay, so if you got that, then well done. Challenge accepted. And that's a lot of people. 30 out of about 70 people, so not quite half, but pretty darn close, nailed this with the right answer. Some of you guys got really close, and then some of you guys were a little bit off, but it was a bonus for a reason, and now we're done with that. So this was about twice as long as I was hoping this video would be, but it was really hard to tell who missed what, so I hope it turns out to be helpful as you go through the quiz. I really don't know how it's going to be returned to you. The scores are in Campus, so please check your scores in Campus. And I'll try to set it up so it at least tells you which problems you missed or not, but I'm trying to figure out the Google quiz as I go here, so you'll have to, if you have some hints, let me know. Hope limits are ready to go all right for you. They are everywhere, and we'll be digging into them for the next 4 weeks. You guys hang tight at home, and let me know if you have any questions.